All right, section 2.1. We're basically, at least in this section right here, we're just it's called linear equations. You're just solving for x. Linear. See how pretty that looks? Linear equations. Okay, linear means what? It's a line, right? Okay, so it's a line, a straight line. So if I was to graph these things, which we're not going to do right now anyway, but if I was to graph these things, you just get a nice straight line. So you're basically just solving for one variable. You're just solving for x or a or b or c or whatever letter they put in there. You understand that. So let's do an example. So here's example 1. Let's see. Here we go. It's real simple. This is like pre-algebra, algebra 1 kind of stuff. But we're starting off basic. Of course, you know it's not going to stay like this, don't you? Okay. You've seen that before, right? So here we go. We want to solve for y. And all these things just say solve. And there's only one variable in there, so it won't say, you know, solve for x, solve for y, solve for a, solve for b. It'll just say solve. And then you just solve for whatever letter they have in front of you. All right, so here's the rule. If I'm solving for y right here, you get rid of the constant first. Okay, that's the first thing you want to do in a situation like this. Get rid of the constant first, which is a -4. How do you get rid of something if it's -4? Add a 4. Right, you add a 4, you do the opposite, and you add it to both sides, right? Whatever you do to one side, you do to the other side. Okay, that adds up to 0. That's why we added a 4, right? People ask me, you know, when I'm teaching this, well, how did you know? Well, you just do the opposite of what you're trying to get rid of. Doing the opposite gets rid of something. All right, so 5y equals 15. All right, again, you're trying to get rid of the y. The only thing next to it is this 5, so you have to get rid of the 5. It's being multiplied, so you divide. And divide this side by 5. Cancel out. Y equals 15 divided by 5 is 3. Pretty simple, huh? All right, so let's do another example. I hope they get harder than this, don't you? No? All right. Let's... Actually, the example... See, I split this section up into a couple different parts. The next example in the book is a little bit harder than I think. And I think I saved it for another section. Anyway, let's just do this one. Yeah, we can do this. So here it is. Tell you what. Let's try a different color. Let's go nice little green right here. Does that look green up there? Yeah, you can tell it's green. Okay, so example 2. Here we go. Again, it says to solve. All these say to solve. I'm not going to write that every single time. So I've got 3, and then 2x minus 4. You guys writing these down, or are you just sitting and watching? Minus x plus 5. Judah, that wasn't enough to get you to take some notes on this? Alright, here we go. Now watch, we're not going to start moving things over from one side to the other over here. Over here, the whole reason we moved this over because everything on the left side was already simplified. Everything on the right side was already simplified. So that's the first thing you have to do is make sure you simplify both sides first before you start thinking about moving something over from one side to the other. Again, a lot of people get in trouble because they try to move things over before it's time. All right, it's not time to move things over just yet. Let's simplify this whole left side so we can't do anything else to that left side. So what do we have here? We've got a 3 in parentheses, or we've got a 3 outside this parentheses. What is that? That's right, distribute. That's the word. Distribute it through this parentheses. So that's 6x minus 12. All right, because it just multiplied everything by 3. Everybody good here? What about over here? That's right, distribute the negative. So take that minus and distribute that through both of these. So that's just 7. Now that 7 is not being multiplied, right? It's just a 7. And then minus x, what? Minus 5. Again, let's simplify everything. We're almost ready to move some stuff over. But what can we simplify over here? 7 minus 5 is 2. So it's 2 minus x. All right, now we can get rid of some stuff. Alright, I got these colors here. They're kind of in the way. So, watch this. See, now I made it so I could scooch it up and down. Isn't that cool? Yeah, I worked on this for quite a while last night, actually, to get it all the way I wanted it to. So, alright, so here we go. We want to get x on the same side. Look, I've got an x on one side and an x on the other side. You could do two things. You could subtract a 6x from both sides and move it over to the right, or you can add an x and move it over to the left. I would probably prefer to move it to the left-hand side. All right, plus it keeps it positive. But you can do either way. It doesn't make any difference. I would do it this way. I would say add an x here and add an x right here. Now you could bring everything else down, right? But I like to do things a little bit like all in at one shot as much as I can. So instead of bringing everything down, look, I moved all the x's over to the left-hand side. What about this minus 12? What can I do with that? Yeah, I could add it to the other side. Let's do it in the same step. Is that all right? So I'm going to add 12 to both sides, and we'll do that kind of in the same step. You okay with that? 6x plus x is 7x. Look right here. Negative 12, positive 12 cancels out. It's equal to 0. Equals 2 plus 12 is 14, and the x's cancel out or add up to 0. Yeah, so divide both sides by 7, and x is 2. Alright. Wasn't much more difficult, was it? Nah, just had to know a little bit of distributive property, and you're good to go. Alright. Let's find another good one. Trying to find some that are like the ones in the worksheet. They don't give you an example for every type. Here's a... Well, let's see. No. Let's do this one. We'll call it example 3. Oops. Let's change colors. We're all into the colors now. So let's do yellow. That's pretty. Pure yellow. Okay. So example 3. Where was I? Watch this. 5/6 x minus 2x plus 1/3 equals 2/3. Okay. Again, we're solving for x. Let's move this up a tad. Alright, first thing we do, simplify both sides, right? Alright, so let's do that first. Before we start moving stuff over, let's take a look at the left side. The left side of what? The left side of the equal sign. Any of you guys have Miss Swan for math? Okay, remember she put that line in between here? That's okay when you're first started. If you're beginning Algebra 1 or pre-algebra, that's fine to put that line right there. As you get a little bit older, you don't want to put that line, okay? It's a good teaching device at the beginning, but you'll need to learn to get rid of it. I had kids in my Algebra 2 class, Honors Algebra 2 class, still putting that line there, okay? In college, they don't want you doing that kind of stuff, okay? And I understand the reason for it. It's a good idea, but just to learn it. So, but this is where the line would be. You've got the left side and you've got the right side. You got it? So let's simplify this side over here. Now this is over 1. It's a little bit of fractions. I know they're your friends, right? No, you hate fractions, don't you? But let's do this. Let's find a common denominator. I got 6 and 1, which would be what? 6. Let's find the common denominator. What did I do to that? Nothing. Multiplied by 1, so I don't do anything to that. Alright, so that's a 5x. What did I do to 1 to get to 6? Multiply it by what? By 6. What do you do to the top? Multiply that by 6, so it's minus what? 12x. Okay? Plus 1/3 equals 2/3. Very good. I still really haven't simplified it. Let's simplify that right there just to make it look a little bit nicer. So what's 5x minus 12x? It's negative 7x over 6. Tell you what, in the same step, let's do this. We can do this in our head. How do I get rid of a plus 1/3? Subtract a 1/3. Okay, I can do that in my head. What's 2/3 minus 1/3? It's 1/3, isn't it? Everybody see that? I didn't show it. I'll show it right here. Minus 1/3 minus 1/3. Here's a little bar. 2/3 minus 1/3 is 1/3. We good? Alright, here's the part right here that some people get mixed up with. I'm going to solve for x. So I have to get rid of the negative 7 and I have to get rid of the 6. Let's talk about the 6 for a second. What is that 6 doing to this whole thing up here? Is it add, subtract, multiply, divide? What's it doing? It's dividing, isn't it? How do you get rid of something that's being divided? do the opposite, which is multiplication. So watch. So I multiply by 6. Agreed? What's this negative 7 doing to that x? It's multiplying, right? How do I get rid of something that's being multiplied? I do the opposite. What's the opposite of multiplying? Divide. So I divide by negative 7. Basically, what did I do? I multiplied by the what? Reciprocal. Okay, so if I have a fraction that's being multiplied by x, I just multiply by the reciprocal. That's the same thing as dividing, isn't it? Okay, so it's 6 over negative 7. So watch. Multiplied by... no, I want to keep the x there. I'm not trying to get rid of the x. Right here. I don't want to get rid of the x. That's what I just said. Okay, I want the x to stay there. Okay, that's a common mistake. People do that all the time, but I'm not trying to get rid of the x. What am I trying to get rid of? The negative 7 and the 6. I don't want to get rid of the x. I want the x to stay there. Does that make sense? Okay, so I get rid of the negative 7 over 6. Multiply by the reciprocal to come over here and multiply that by the reciprocal. Okay, I multiplied both sides by the same thing, didn't I? Alright, look what happens. The 6 goes, the negative 7 goes. That's the whole reason I did that. The whole reason is I wanted that x to stay right there. If I would have multiplied it by an x, guess what would have happened? Then I would have moved it over here, and that wouldn't have helped me at all. Okay? Would you agree? So, the x is right here, so I've just got a plain old x. Now work this thing out. Well, you could go 6 over negative 21, but it would have to simplify. I would simplify it right here in the multiplication. 3 goes into 3 once, 3 goes into 6 twice. What do I get? 2 over negative 7, or negative 2/7. Just like that. Make sense? Alright, so I added the like terms first. You had to find a common denominator because they were fractions, alright, but they still add up, you know, just like any other number does. You just have to do a little bit extra, find a common denominator and all that good stuff. Then we had to get rid of this fraction that's being multiplied. That's where a lot of students get in trouble. Alright, they're just not sure what to do with this. Well, I broke it up a little more simple, I think. I multiplied by a 6 to get rid of the 6 on the bottom, and I divided by a 7 or a negative 7, put it on the bottom right here. They cancel out, do the same thing to the other side. Alright, just work that thing out, bang, there it is. Don't put that into a calculator, give me a decimal number. Okay, that's ridiculous. People do that all the time. I don't know why. Okay, this is an exact answer. Alright, just keep this answer right here. Don't throw that into a calculator, give me some decimal. You understand that? Right? Keep that answer. I mean, look, I don't know why people do that because it's an extra step that you got to take. Why bother doing an extra step? Why not just keep it like this? Wouldn't you agree with that? Yeah, I would. Okay. Let's do another. How about, let's do a decimal. Let's scooch that up. Alright, let's pick a pretty color. Also got some colors down here. Jade. Where was that? Yeah, it might be a little dark. We already did a green one, didn't we? Global squash. Where's that? Right here? Okay. I have no idea. Alright, so let's do another example. What example is this now? We haven't 4 yet? It's somewhere around there. Doesn't really make any difference, does it? Alright, let me find you a good one. Alright, let's do this one. We had a little practice with fractions. Let's see if we can do a little bit more with fractions. This is kind of the same problem. I'll go a little quicker on this, okay? Kind of the same problem, except look at my x's. Remember on the other problem I had the x's on the same side? This time they're on different sides. So, what do? You could always take the x and always put it on the left-hand side. I know some people that they'll do that every single time. It doesn't make any difference what the numbers are. They'll always put the x on the left-hand side. I'm kind of more particular about this. I would rather take the smaller one and put it on the side of the bigger one, just because it will come out positive. Right? Because watch, if I subtracted a 4/5 x from this, I'd get a negative 3/5 x, wouldn't I? I could deal with a negative. It's not that big of a deal. I just did in the last problem. But I don't know. For me, I kind of like to make it as easy for myself as I can. So I would subtract a 1/5 x. But before we do that, what did I say to do to the left side and the right side before you start moving anything over? Simplify the sides, okay? So what can we do? These two right here, okay? We can add those up. So I'll tell you what, let's just do these off to the side. That's 3/4 minus 1/2, right? Common denominator is 4, so that's 3/4 minus what? 2 times 2, 1 times 2, 2/4. Should be able to do that in your head, right? Because 2/4 is the same as 1/2, right? So what's 3 minus 2? 1/4. So 3/4 minus 1/2 is 1/4. Or you could have just looked at this and said, oh yeah, 1/2 is 2/4. 3/4 minus 2/4 is 1/4. Couldn't you? Alright, I just showed it to you just for the sake of showing you. Plus 1/5 x equals 4/5 x. Now what we want to do is get the x on the same side. Now we're going to start moving some stuff over. So I would do this. This is what I would do. You don't have to do it this way, but this is the way I like to do it. Okay? See what I did? Subtracted a 1/5 from both sides. Look what happens. That goes. I've got a 1/4 equals, what do we get here? 4/5 x minus 1/5 x. 4/5 minus 1/5 is 3/5 x. Now, what's this 3/5 doing to the x? It's being multiplied, right? Remember what we did on the last, was it the last one or one before? I don't know. Yeah, what did we do? How do we get rid of that 3/5? Multiplied by the reciprocal, which in this case would be 5/3. So you come over here, multiply this side by the same thing, which is 5/3. Does anything cancel out like it did before? No, because nothing goes into 4 and 5. 3, no, doesn't. So all you do is multiply straight across the top, straight across the bottom. So x is equal to what? 5/12. Leave it like that. As long as your fraction is simplified, leave it like that. Okay, if it wasn't simplified, then simplify it. But it is. Don't change it to a decimal. Just keep it exactly like that. We good? Ready for another one? When do we get out of here? 20? 12, 20, 10 minutes. Okay. I pick another color. How about fresh lavender? How's that? Sounds a little fruity, but that's okay. Alright, let's do one more. Let's do one with a decimal. So let's go 0.01p plus 3.1 equals 2.03 p minus 2.96. Okay. First thing we do is to simplify both sides. Well, look at the left side. Can you really simplify that? No, because that has a p that doesn't. You can't add those. You can't add those. So the left side and right side already are simplified. So now what I want to do is I want to move the variables over and the numbers over. So let's put either the p's on the left-hand side or the right-hand side. I probably would put, see, since this is smaller, I'd probably put that over here, okay, on the right-hand side, just so it stays positive. That's the only reason I would do that. All right? So I'm going to subtract 0.01p. Do the same thing over here. Subtract 0.01p. All right? In the same step, I got the p's on the right-hand side. Let's take this minus 2.96 and move it over here to the right-hand side. I would do that by adding 2.96 and then add 2.96 to this. What's important about decimals? I mean, you can use a calculator, I guess, but what's important when you're doing this by hand as far as decimals are concerned? Do what? What'd they tell you? Yeah, make sure it lines up. Okay, you've heard that for years, haven't you? By your elementary school teachers, make sure the decimals line up. Okay, so that's pretty important. So let's see what we got here. That cancels out. This one right here cancels out. Let's do this. I've got, that's a 6, that's a 10, carry 1. Am I doing that right? and that's a 6. Let's check my math. I think that's right. Okay, what about this? If I subtract, that's just a 2, so it's 2.02p. Agreed? All right, use a calculator if you want. Solve for p. This is being multiplied, so we divide by 2.02. Come over here, divide this by 2.02. Should be 3.03, right? Is that right? Somebody do that just to make sure that I'm pretty sure. Well, it might just be, I don't know. You don't have your calculator. Alright, of course, it's 3. It's not 3.03. Yeah, absolutely. But don't think that, I mean, like 5/12, that's not so rigged, right? So you never know. I wouldn't go by the fact that, oh no, it doesn't come out nice and pretty. So, like back when you were at elementary school or even pre-algebra and stuff, a lot of them, even Algebra 1, they came out nice and pretty, didn't they? They don't always come out nice and pretty, but that one happened to. They happen to. Well, these are actually from the book. They're not really examples. Let's do one more. We got some time. Let's do one more. And what do you think? Let's go sunshine. It's a sunshiny day today, isn't it? All right, here we go. This is the last one we're going to do. So it's 1/5 times 2x plus 5 equals 1/3 p plus 2. Alright, we did one like this earlier, didn't we, with distributive property? Well, let's do the same exact thing. Let's distribute through this. So 1/5 times 2x. Now how do we do that? Well, it's just 2/5 x, right? Because that's 2 over 1, right? And that'd be 2 over 5. Agreed? Plus, what's this? This would be 5 over 1. 5 over 1 times 1 over 5 is 5 over 5, which is just a 1. You should be able to do that in your head. Equals. Oh, I put p, didn't I? Because the book says p, and I didn't like writing a p, and I forgot. We'll just keep that x. All right, so 1/3 x. Not much you can do with that. Just 1/3 x plus 1/3 times 2. Well, 2 over 1, you multiply them together, it's just 2/3. All right. Get the x's on the same side. So now this time, watch. This is smaller, so I would take this 1/3, subtract it, put it over here. You got it? So subtract a 1/3 x, subtract a 1/3 x. Minus 1, minus 1. Now watch, instead of putting 1, I'm subtracting it from a 2/3. What's a better way to write it instead of a 1? Think common denominator. What is it? 1 over 1? That's still the same thing. I want to think 1 over 3? Is that the same as 1? It has to equal 1. 3 over 3, right. 3 over 3 is 1, isn't it? You never did that before? With fractions? Because look, you subtract a 1. Isn't that a 1? 3 over 3? Yeah. Okay, so 2/3 minus 3 over 3. Don't you? That looks a lot better, doesn't it, than just putting minus 1 right there? Because you're going to have to take that 1 and change it to a common denominator anyway, and it's going to come out to that. You should be able to do that in your head, especially if it's a 1. All right. So what are we going to have here? I don't have common denominators, so I got to figure out what a common denominator is going to be. Let's do it the old-fashioned way. Remember you kid, you did it off to the side like this? Okay, put a minus here. So 5 times what? 3. 2 times 3 is 6. What's this? 3 times 5. 1 times 5 is 5. So it's 6/15 minus 5/15, which is 1/15 x. That added up to 0. That one right there added up to 0. And, oops, I lied. This one, boom, boom. Okay, those crossed out. They added up to 0. What's this? 2/3 minus 3/3 is? 2 minus 3 is? Negative 1/3. Let's multiply by the reciprocal again. So multiply by 15 over 1. Come over here, multiply that by 15 over 1. Cancels out, cancels out. X equals, look at this, 15 over 3. Or you could do this. 3 goes into 3 once, into that 5 times, and what do we get? Negative 5. Okay? They're basic steps. You just have to know how to work with fractions, okay? And I'm telling you, you got to learn to work with fractions. It's going to make things a lot better for you instead of just, well, I got a calculator, I can just throw it into a calculator. Well, don't just rely on a calculator all the time. All right, make sure that you're doing this. So our homework is section 2.1a. I think I have two sections of this, like an A and a B. All right, this is the first one. All right, that's it.